Login accepted.
All right, welcome everyone. Today we're going to go through the basics of IP networking. So I'm going to go over device addresses, the OSI model, and how routing actually works. And so I want to kind of like uncomplicate it because when I was studying for it, it was like really complicated and I really couldn't find any, things online that would like help me. Oh, all right. So this is where we are in the schedule. So yeah, and then yeah, please become a member and buy this link. All right, so here's the table of contents of what I want to go over today. So I'm gonna start with like the devices you'd use, the OSI model, just like how everything's like logically broken up, IP addressing, device configuration, like how to apply IP addresses to actual devices, and then how to set like IP routing on each of the devices. So yeah, we're gonna start with network devices. So first I'm gonna start with a router. So Cisco routers, like the ones I'll be referring to throughout this, is going to be the enterprise routers. So it's going to be like these ones over here, like the white ones, and not just like your typical home routers. So they're kind of like rack mounted, and they have no Wi-Fi in the sense that like you can't just like open your phone and connect to them right away. Um, but your typical home router is different, where it's kind of like an all-in-one with like multiple devices all in one. But yeah, if you could see, so like when I'm talking about a router for the rest of the thing, I'm talking about that one, like the big rack. And if you notice also, it doesn't have that many ports, like as much as you'd think, because yeah, I'll get into why. All right, so here's a switch, and so they operate within the LAN. So oh shoot, it didn't- all right, yeah. So here's a switch, and this operates within a LAN. So that means like the routers operate kind of connecting LANs together, but the switch is in the LAN itself. And so they use MAC addresses to talk to one another. And so you could say like once the router kind of makes a decision and it gets to LAN, the switches is kind of what's like sending it out to like each of the devices. And if you notice here, like what I was talking about before, how the routers don't have that many connections, like this is why switches exist. Because if you look right there, there's like a bunch of them. So for example, I would say if you've ever been in a lab room in Cal Poly, like you'll notice that like all of the devices and all of the laptops or not laptops, like the desktops that you use in the lab rooms, they're all connected with Ethernet. And it wouldn't make sense to have like 100 routers or something where you individually connect like three or four like to the four ports that were there before. It makes more sense that you have a switch in each of the rooms and then all 20 devices would connect to one of those and then this would connect to like an uplink router that would do all the routing decisions. So this is like a where am I? Oh yeah, a router in traditional networking. So this is how like a home router works, where first you connect to your internet service provider, which is like ISL, and this ha handles like the routing decisions and where a packet would go. And it has a built-in switch. So if you notice this like kind of beefy home router, like it would be kind of an all-in-one where not only is it a router that makes routing decisions, but it's also a switch and an access point. So what I was talking about before, where a router, you can't just like open your phone and connect to an enterprise grade router, is because first what you'd have to do is like they kind of split it up to where first you'd plug in a switch into that router and then an access point into that, and so you connect to the actual access point. But like yeah, like you can't connect to just like a router just like that. And then yeah, this just does all the IP addressing and everything. So now I'll go into, so I'll start with layer one, where it's a modem. So you could think of computers as talking in ones and zeros, like they mo like mostly talk in binary. So when you think of a IP address, like we see like 192.168, like blah blah, but like they just see 0 1 0 1 0 1. And traditional internet media, like when you're sending like cell phone signals and stuff like that, is in a different type of signal where you could say, for example, 2.4 gigahertz or like 5G LTE. like that type of signal is different than like the signals that our computers talk in. So what a modem does is called a modulator demodulator, and modem for short. So it takes the signal from the computer, and during modulation it's like the computer going to the network signal, and that's digital analog. And demodulation is the opposite, where you take an analog signal to a digital signal. And so yeah, this is basically this like video kind of shows like the signal, and this is pretty realistic because that's like kind of like the signal how it talks in a computer, and then once it goes over the internet, like you kind of would think like since like signals are signals, but they're different devices. All right, and then we'll go into end devices. So end devices are like the devices you'd use, like what you're using right now. Like that's like what you connect with. I don't want to spend too much time on this because you guys probably know. So they have a MAC address and an IP address usually, and they're just like the starter end of a connection. By start, I mean like if you think about it, like when you're on an application on your phone, that's kind of like the very start of it, but it's also the end of it because it goes through the whole OSI model and then goes back up to the application layer, and then that's what you're seeing in real time. All right, so here's an example I wanted to show is eduroam. So like the SSID, like if you were to pull up your phone, you open Wi-Fi, the SSID you'd see is eduroam. So that's like what you connect to. And so there's access points all around campus. And so like every time you connect to eduroam, you're not connecting to like the same router per se, like you're connecting to like whatever access point you're near. So they all have like wired backbone into like a switch and a router. But notice how like when you're walking around campus, if you were to use your phone and you're just walking everywhere, like you wouldn't be like keep getting disconnected over and over. And this is because your login is checked by a radius server. So when you initially log in, uh it goes to a radius server, it remembers your login, and there's another thing called IEEE 802.1x. And so what that does is every time you go to a new access point, it goes back to the radius server and it checks like, okay, this guy logged in like earlier today, so we know he's good. So no matter where you go after you log in the first time, and this kind of like ties into, when you're always doing the verification or whatever, like the first time, you log in, you get like that second two-factor authentication thing. That's kind of in a way like once you do that and it knows like you're good, like no matter where you go, you'll be connected. So here's kind of a example of an enterprise network. So you could kind of imagine like this is like CPP in a way where like all of these like it kind of starts with the router, or yeah, the routers in between. Like you could think of those as being like the main like decision makers. And you could even think of like those two routers are in like completely different locations, and then that like little lightning like cable thing in between is connecting those two places together. And so if you see like, or when we think about like traditional home routers, and like you just kind of plug it into the wall, plug it into the modem, and then you're good because it's like an all-in-one. It's kind of for ease of like setup. Like they don't want like people who are non-technical to like have to go through, have to set up like an enterprise grade router and then an enterprise grade switch and then an access point. But when it comes to schools and stuff like that, since you want like a lot of people connecting to them and you want like fast Wi-Fi, you kind of set it up like this where you start a router, you go to a switch, and then you go to an access point. So if you see that like those dashed lines up there compared to like the solid lines, like that means it's connected over the analog signal, where it's like connected over 2.4 gigahertz or whatever your network is set up with. And then like all the dark lines are directly connected. So you notice that like almost nothing is directly connected to a router because it just doesn't make sense. That's like a waste of like a router port to use it. And realistically, most devices like it wouldn't even be able to send data as fast as a router could. So it just makes sense to send it to a switch and then have the switch kind of like spread it out to like everyone else. All right, so now I'm gonna go over the OSI model. So yeah, this is the OSI model, and these are some mnemonics. I like to remember it. Like I use the top one personally, but I think I've seen other people using the bottom one. So it's like all people seem to need data processing, and that goes down the layer like application, presentation, session, transport, network, data link, physical. And so this is just like a good way to remember it. I feel like people like overemphasize the OSI model, talking about like, oh, like it's like important to know, but I don't know. To me, it's pretty overhyped. But the thing like like I'm gonna go over is mainly layer 2 and 3. I feel like that's the most important. And in the scope of CCNA, like that's definitely the most important because that's basically like what is affecting. And also like I guess layer seven, because that's what you see. That's like the application like you're using and that's what's connecting like everything. But everything in between, like in my opinion, like it didn't even come up on the test for one. And like I don't know, like I don't think it matters that much other than physical data link network and then application. Like those are like if you were to take a CCNA or something, it'd be 90% of the test probably. And then the maybe transport is like I think ports, like port numbers and stuff like that. So that's like somewhat important, but not too important. All right, so now I'm gonna go over CIDR notation. So normally when you set up a like a IP address or when you're just like talking about it in general in networking, you normally see it like this. It'd be like 192.168 dot 1.0 slash 24. Like you just always see the slash value. And so this kind of defines how many hosts can reside on that range. Like it would be like if you could see like the thing on the side, like that slash value is like how many bits and like how many IP addresses like actually fall under that range. So routers use CIDR to know like which address like an IP belongs to, and but switches they don't really care about CIDR because they don't use IP addresses and they use MAC addresses to talk to one another. So this is mainly like the CIDR stuff is like only in terms of routers, and end devices also use CIDR to know if it device is local because like if it's not in this range, like a device kind of knows this range because it's connected throughout like with the router or whatever it be. But if it doesn't know that, then it must send to a router, and then the router has to make the decisions of like what protocol to use and like how to send it. So, okay, so how to determine host and a subnet? So, can anyone tell me the difference between these three addresses? Yeah, exactly. So like even though they are technically the same like number and address, they're like completely different like meanings because they're different ranges where it's like they some of them even overlap where like this slash 24 would be like 192.168.1.1 to 255, for example, and then the slash 28 would be like 192.1 and then 128. Like it's like, like half of the other one. Yeah, sure. Uh, but yeah, it's like dot 31. I'll get into yeah, that too. It's not exactly 32, but yeah, like I go into that later. So you could also only start subnets in multiples of 2 to the power n, and I'll explain like the math of like how I like figured out like myself and like how it makes sense to me. But if you were to set an address that's not in the proper subnet range, so say for example you set like 192.168.1 dot like it's like a odd number or something, and then you also set the wrong subnet mask. Like it would just give you something called a bad masker. It'd say like bad mask for this. And you would probably see that a lot, like if you don't understand subnet, you know, like addressing and stuff. And if you also see the 255.255.255.0, so that's basically how the computer would read slash 24 slash 28 slash 30 is because like that's like what CIDR is to the computer. So when you do slash 24, like that is 255.255.255.0 and it'll make sense. Like you just have to do the reps and over time like it'll make sense like when you're, talking in between. So all right, so here's how I taught myself how to do it. All right. Um, so first I start with a slash 32, which is a one host group. So what that means is like a slash 32 is basically like there's literally one like address in the whole thing. It'd be like 192.168.1.0 slash 32 would mean like your only address you could use is 192.168.1.1. And so then like say for example you want to find a slash 28, I say in this example, what I do is I do slash 32, which is like the absolute lowest you could go, minus 28, and the difference would be 4 in this example. So you could think of n as 4, like for this specific one. So when you have that, you start by subtracting it by 256, and so then you'd get the subnet mask of 255, 255, blah blah, like ending in 252. And so that's like how you'd find the sub, and this applies to everything. In like, so imagine you had something with the address slash like 27. Instead, it would be um 247. Like it would just be like something, and then like you'd subtract that by 256, and then that would be your address. Like if I go back to this thing, you could see it more clearly. Like how when you start with like the host of one, if you see like it has like one IP address, you'll also see that the subnet mask is just all 255s. Like that's what you'd consider like a just like a one host address range. And then as you keep subtracting one from the CIDR notation, from the slash notation, you add two to the power of um like host wise. Like it would be like two times two to the power two, to the power three, to the power four, and that's how you see 8, 16, 32. And then each time you see this address range thing, you'll notice that number is being subtracted by the initial 256. I don't know why, but like when I was studying for it, it made no sense. But like you subtract it from 256, but like the host address is 255. Like I don't even know about that, but like just know like when you're subtracting it, like if you see, for example, the 4-bit one for slash 28, you subtract 16 from that. Oh wait, I literally did the example wrong. But yeah, this is actually a slash 28. But yeah, because I was thinking like it's I said n equals 4, but I meant 2 to the power 4, so that's 16. So yeah, like since it's 256 minus 16, it'd be 255s all and then 240. And then so that's what the router reads at slash 28. And if you did 224, for example, it'd be slash 27. And then that's how it knows like what the address range you're using is. Okay. Okay, yeah, and then I'll go over the last part of this where so now that you have your like subnet mask, you want to know like how many hosts there are. So it's to the power n is like what you subtract to get your subnet mask from 256. And then now you have to subtract 2 from that because there's two addresses you can't use. That's what he was like brushing on before, is that like technically the address range would be 192.168.1.1 to 31. It wouldn't be 32 even though it technically said like it was like in 2 to the power of whatever. Like it would be, 2, 4, 8, 16. Like you would almost think it's that, but in actuality, it would be like all of those subtracted by 2 because you actually can't use 2 of the addresses. Yeah, exactly. I'll get into that more, and then we'll do some practice with like some of the examples. So yeah, here's like some of the practice of the math. So kind of just like keep these in mind and like kind of try. You could even try like try one of the problems yourself. Because yeah, I don't know. I feel like this was like the hardest part of subnetting for me personally, was just like understanding like how the ranges works, and you just have to like understand like binary pretty well, where it's like to the power of stuff. And then yeah, because like you notice like even though these three are like the same like number wise, and the only thing different is a slash, like that completely changes the whole thing. And so yeah, what you're talking about is the broadcast address. So say you wanted the 192.168.1.1 has a like 256 if you put like 2 to the power 8, that's 256, right? So like you would think it has 256 addresses, and it does, but one of the addresses it is for the broadcast address, so that means it's the very very last address. Like 255 is like the absolute last address, but you can't use that. That's like used for something else. And when I say you can't use that, it means like it is still doing something, but it's not something you could apply to a device. Like if you did that, like you get a bad mask error. Yeah, you'd probably get a bad mask error because it would just be like, this is something you can't use. And then the network address is like 192.168.1.0. So you technically can't just use the first one ever because like that's just not a valid address. Like you have to start with dot one, dot two, dot three, dot four, and so on and so forth. Like you can't start with the dot zero because a dot zero is just not valid. Like no matter what you do, even if you did 192 blah blah 2.0, like you just can't set that to a device. So that's not in the usable address ranges. Okay. All right. Well, I guess it just shows all the answer. But like for me, like normally it like does a thing where it like shows them one by one. But or actually I could just like is there like a marker? I'll just put it up on the board. So here's the address, and I'll give you guys a second, and like I want you guys to see if you could figure out how to find the network address, broadcast address, and the actual usable address range. And I feel like this is the only thing I'm gonna actually like, like do a practice problem for because like this is like literally like the only hard part of like the test where it's like you think it's a lot harder than it is, but once you get to math, like it's just like I don't know, like this is literally 60% of the test. So I don't know, I'll give you a minute and then I'll just like all right, I think that's good. So does anyone want to start with the network address of the person? I feel like this one's easy. Yeah, you can just start with the network address. Yeah, it's just this. Yeah, by the way. Yeah, you could say the broadcast address, and then if you know the usable address range, you could say that as well. Yeah. Fine. Yeah. All right. So does someone want to try the other one? Like 128? Does someone try? Sure. Oh yeah, go ahead. You want to be network? Yeah, you can just do all of them. Network, broadcast, and then usable address range. Okay, all right. Or you could say the network address at least. Yeah, yeah, it's just this. Okay. Um, so does anyone else want to do the broadcast or usable address range for this one? Yeah, the second one. Or not you, not you. You already know your stuff. Yeah, go ahead. 255. Yeah, yeah, exactly. So because yeah, so like normally if you think about it, like the slash 24, like that would also be 255, but since you took off one of the ciders and you started halfway through, like the address range is halfway. So it's like I don't know, like I feel like that makes sense, But yeah, do you want to say the usable host range or no? 126. Oh, or like yeah, like the actual range, like starting and ending. Yeah. All right. So does anyone else want to try the last one? This one's pretty good, I feel like. No. All right, well, this was easy anyways. So the network address is just up there. And then the broadcast address is the wait. Oh yeah, it'd be three because the cider group is so small, so slash 30 and like the lowest it goes is slash 32, so it'd only be like yeah, one, two, three. Yeah, so, or yeah, the usable address range would be 1.1 and 1.2 basically. So that's actually useful. And like the reason why this exists is kind of because when a lot of the problems you would see even in CCNA, it'd be like, what is the most like optimal address range you could have? It'll be like you have 80 buildings and each of them has three devices. So that's like 240 devices. It'll be like how many like what address range should you use? So it'd be like oh you'd use one that has like what 256, right? That'd be like a slash 24. Or it'd be like, oh, you have a router of links with four connections, or like five, six. It'd be usually is odd numbers because they want you to kind of go up to the next range of two to the power n. Yeah, like oh, how the slash correlates with the subnet mask. So it was like it was kind of what I did before, but so like imagine this, like do you see on the screen where it's like two to the power something minus two equals something? So instead of doing the minus two before even doing that, you just take the two to the power number and then just subtract it by the 255 like you subtracted by that, but even though the absolute host route, like the one host addressing is 255. But like when you're subtracting it, you subtract from all of those ending in 256. So like if you could see there, two to the power two, if you subtract that by the all 255s and 256 is 252. For that one, it's two to the power five, which is 32. You subtract that by 256, you get 224. And same for all of those for number one. So you see how it's 256? you're taking all 256 that ends in with, so it becomes zero. Yeah. So then that's why like for this one, even though like it doesn't start at zero, it starts at 128 since it's the next cider one with half the address range. So this address range you see has 256 since that, and that's slash 24. This one's slash 25. So it's like one like two to the power like octet lower. So it'd be 128, right? So since you're starting at 128, like you add 128 to this, and then that's like the last host. And but it also resets. I didn't mention that, but it resets every time you get to like 256. So for example, if you were to overflow, because it doesn't go like it goes even farther and farther, where it goes to slash 16 slash. You could go to slash zero if you really wanted to, because like and that would be like millions of addresses. But like nobody does that. That doesn't make sense. Like optimally, like you'll never see that like done. But like you could go to that level, and each time, like you'll notice, like you could take off, like if you were to do 255.255.0.0, like that would be like millions of addresses, like because like each of those, like one that you're taking off of that third octet, where it's 255, 255, 255, like like how that one's zero. Like imagine, so that's 256, right? So imagine you wanted 512. Like what would you do? Like you'd have to borrow one basically from the next bit. So it'd be 255, 255, 254.0. So then that would be 512. And then you could keep doing that. Like if you wanted to take another bit off that, like that would be like something like thousands, and then thousands, 10,000s, and whatever. So like yeah, go ahead. No, no, no. Like, I was
On broadcast this, it's just one more than last.
Yeah, yeah, or you could think of it as like you find the range and then you can't use the first network address and you can't use the last one. And then like the range is just that in between. Yeah, yeah, like the beginning and end you can't use, right? Um yeah. Oh yeah, yeah, that is true too. And one of the questions I would get on the thing is like, it would be like, what is a slash 24? And it would give you like a bunch of ones. It would be literally like 1.1.1.1. I think so like, I think 255 and stuff like that in binary wise, like since 255 is a maxed out number, like octet wise, if you were to break it down to like straight like digital like level, it'd be literally eight ones. It'd be eight ones. Like for all 255 address, it'd be eight ones, eight ones, eight ones, eight ones. Like that would be every octet to the computer. So like what he was saying was like that, like imagine it was a slash 24, it would literally be like one, like that 255 would be one group of one, that next 255 would be another group of ones, and then that would be another group of ones, and then so that's 8, 16, 24. Yeah, that would be a slash 24, if that makes sense. Yeah. But that makes sense. Like, I feel like that kind of makes sense. And I need to go to the other stuff that's hard. Okay, so this is MAC address. I don't know. This doesn't really matter that much. Like you don't really like interact with it at all. It's like important for like verification and stuff like that for the most part, where like if you wanted to like make sure like a real device is a device, like you'd use this, but like for the most part this doesn't come up because it's like this isn't a logical addressing. It's straight up like, oh, like this physical thing is like this thing, it's not like a you could set it or you could change it or you could set addresses or like arranges or anything. So yeah, the routers don't care about it. Like it's most of like a LAN thing, and it's kind of just to like see like what device what, like if you had a MAC address to like anyone in this room, like you could like pinpoint like who's who. But all right, so now I'm gonna get into device configuration. So basically device configuration and packet tracer is like pretty simple. It's like the device on the right, you click it, there's like the physical tab up there, you go to desktop IP configuration, and then you straight up just type in the IP address. Like it's really that simple. And this also applies to real life. Like this is also like exactly what you do for a real like end device configuration. So you would just, go into search up network settings in your whatever Mac OS or Windows, and then just type it in. This doesn't make sense. Like for the most part, like even like when you're learning CCNA and stuff like that, like almost none of the stuff like genuinely applies to real life. Like almost everything uses DHCP, where it's like you have to know like how the addressing works, because you have to know address ranges at least. And then what you do is you basically set up something called a DHCP pool where it's like I want like 500 addresses from like 192.168.1.0 to like I don't know 2.255 or something like that. And so then the DHCP will dynamically give out addresses to everything. That makes a lot more sense because it's like why would you say like, oh, this device is this device, like we've kind of gone past that where it's like all manual and like static configuration. Like this doing like if every student had to do this, it wouldn't make sense. So DHCP is like what we use now. All right, so here are privilege modes. So you start, this is like you open a router, you click enter, and this is like the first thing you see, like is like, or it'll boot up. It takes like a few seconds. And even if you use packet tracer, this is why packet tracer is good, is because it literally does like logically what like all of the like real routers would do. You'd have to wait 30 seconds for it to boot up and all this. Like I worked on a router like in real life and like it takes so long to boot up and it takes so long to like flash. It takes like 2, 3 minutes. But yeah, so you start in the first one, and then you'll notice the level you're at is right next to the name of your router. So yeah, I just named it myself. And so you start at user exec, like you can't do anything there. Like I genuinely don't think like you could actually even like do a command. So first, huh? Really? I thought all the shows were in enable. Yeah, yeah, that's true. I like it. There's probably like some stuff you could do like show why like you would see stuff and it'll be like very bare bones, but like I feel like even still, like in the scope of the CCNA, like there's literally nothing you could do in user exec mode. Like there, like the first step, or like I messed up here, like in the thing I should have wrote enable, but like I'll get into the abbreviation thing. But like that's just like my old habit of like I just like cut off everything because technically, logically, like enable is the same thing as en. So like when I was doing like when you're doing the test and stuff like that, you don't have that much time. So like you just have to like kind of like go through with them like really quickly. So then when you type in enable, you go to privilege exec and your thing changes to a hashtag. And then like you go into configure terminal, which changes to the configuration mode. So like this is basically where you do everything. Like you will have to do these reps like a million times if you ever do this. Like or if you ever like set up a router or anything, like you can't do anything on user exec and you can't do anything on like privilege exec, like really. So you have to go into global configuration mode. And like this is where you could set up IP routes. This is where you could set up like groups like the DHCP pool thing I was talking about before. Like this is where you'd set it up. And then they also have like the sub modes, so you kind of know where you are at. So like imagine you're like, oh, I want to set this device on this port. Like it'll tell you you're in configuration. IF means you're in interface configuration mode, like you're configuring interface. And then you could also do it to the lines as well. So that's called like line configuration mode where the line VTY is like virtual teletype. Like if you guys know what SSH is, it's like that's what you configure. Is like 0 to 4 is basically like the 5 like virtual teletype connections you connect to, and then you know configure the router. Right. So yeah, this is what I was talking about before. So these two are like logically exactly the same. And like yeah, there's like no difference in like what they do. I think I added like one different thing where I had to like host my name or whatever, but that's not like a logical difference. Like I just changed the name of the router. But like for the most part, they're all the same. If you see, I don't ever write IP address, I write IP add. And it honestly makes more sense to do this because like imagine you misspell IP address, like it's just like a, like time waste. And the same thing with like no shutdown, you can just do like no shut and then like configure T. I've never write configure T. I never write enable. I only write like en conf T and then I get into it. And then like the gigabit, like the interface name, like you could just write G. Because it's like if you think about it, like what else would end in that, you know? Like how could you get that far and like there's another thing that ends in that. So like the router knows that and it's just like, okay, like we know what you're trying to say. All right, so what that configuration does is like it just set it to like this, like whatever. All right, so now I'm gonna get into IP routing. Okay, so now we know like what each thing does, like what routers do and stuff like that. But like how do you get from like one router to the other router? Like that's like kind of like your main goal of like IP networking is like you can like obviously set up like a home router and everything, but like how would you be able to like communicate with other routers? And that's what I'm gonna show. So there's things called dynamic routing and then there's things called static routing. So dynamic routing is basically what I was talking about before with like the DHCP stuff. Even like everything we use today is all dynamic because it doesn't make sense to manually configure anything at all. Like the only thing you should be configuring is a dynamic configuration where it's like you configure it and then after that point, like it's doing it all itself. So OSPF and all this stuff is like it's a link state protocol where imagine like you could do it where you set up all the IP routes manually, and then now it's like, okay, this guy connects to this guy connects to this guy. Or you could do something like OSPF, EIGRP, or BGP. And like so OSPF basically what it would do is like there's two routers on each side of it, or it knows all of its connected routers. And what it does is like through those links, it floods something called LSAs, which are like link state acknowledgements or something. And then like through that, like every router knows all of its partners now. Like because it's just flooding it like throughout the whole time and is doing that like autonomously. And each of these things, like even EIGRP, it has its own thing like that. It uses like, whatever, like next hop count and stuff like that. And then, there's like BGP. And then so what I'm going to show you right now is static routing. So basically what static routing is and how it's different from like the other ones is you're setting like the beginning and the end. Like it's not like, oh, like the OSPF is like, oh, this is the best path we could take to this network, so we're gonna like set it ourselves. It's more of like I'm literally gonna like tell you where to take like the information I want and then where to put it. And like this is the most like optimal way when it comes to like just understanding like how like it moves. And I feel like it's the most like basic. Well, why did I do for this one? Okay. So yeah, so first we'd start with network one. So this is what we'd call like next hop IP. Like this was like really confusing. This was one of the most confusing things because like not only do they do like next hop IP is where you start, but it's also like the command to slip, which you'll see. So when you're starting, like imagine you're starting at network one, like you're network one, and then you want to move to network two. Like you'd consider this the next hop IP. And if it was the other way around, like you're in the destination network, like network two, like you would flip like where the next hop is just based on like which one you're looking at it from. So um like yeah, so this is like the example I'm talking about is like it's going from this one to that one. And then this would be the actual command you'd configure. So this was really confusing because it's like it's IP route destination network. Like you literally say like IP route, like where I want to go, and then the subnet mask is the subnet mask of the destination. So it'd be like where I want to go and what the range of people it is. And you could even like set it to where like even if like imagine the network was that like 192.168.1.0/24, so it's like a bunch of addresses, like 256 like people are on that thing, and you're like, wait, I only want to send it to like two people in that. You could actually change this IP route to be like, I only want to send it to 7 and 8, so I'll make it 192.168.1.7, and then you specify the CIDR range as like, 2 or 3 or like whatever addresses. So you could even change it like that, but that's like more advanced. But so the next hop is like where it's originating. Because if you think about it, like next hop makes more sense because if there's like 5 or 10 routers in here, like imagine you put like a router in between, like then the address going after that is the next hop. And then if you put another router, the address going into that is the next hop. Because usually you don't see it like this where it's only two routers, there's next hop and a destination. It's usually next hop, next hop, next hop, next hop till it's the destination. Like the destination doesn't change, and that's why you set it up as like the first thing in the command, and then the next hop is like, all right, what's sending it to that, and then what's sending it to that, and what's sending it to that. Like that's how it kind of like logically like makes sense because it knows where it's coming from or like the link it's coming from. Like it's like, oh, it's coming from 1.3. So it's like, okay, now it's coming from 1.5. Okay, it's coming to this. But like the thing is like the destination never changes. It's going to the same place. So it's like you just have to configure that for each of us. All right. And then so this is how I kind of thought of it. Like this is kind of like a simple example. So instead of addresses, I'm just gonna use the letters like A through F because I feel like when you add too many numbers to it, it gets confusing. So like this would be just like a logical IP route where if you see I color coded like what route's going to what. So you would configure this red like route on router 2, and like that's the function of the route. Like that's what the IP route is doing. And then vice versa for the green one, like that's what the router 1 is like logically doing. It's like, and this makes sense like even like like with the device like logically because the router knows everything it's physically connected to. So if you notice, it physically knows network 1, it physically knows up until D. Like that's what it's connected to. So it knows like up until that point, and the same goes for the other router where it knows up until C. Like router 2 knows up until C. But it doesn't know the destination it wants to get to, like whether it be A and B or E and F. Like it has no idea. So that's what the IP route kind of enables is like, hey, like router one knows D, but like what's after D? And you set it up to where it's like, okay, like F is my destination. I know D. Like, can the router deal with it? And that's what you're sending. That's what the IP route is sending to router two. It's like, hey, like I know like D at least, and like I know I can send to that, but I don't know F. So like, can you figure it out? And that's what you do to both of them. And so, does someone want to try like placing the letters into this command to like see if they could, all right, go ahead. Yeah. Okay, yeah, yeah. Oh, I was gonna go over that as well. So you would think like each time you'd have to do a next hop, it's like next hop, and that. But like what I was explaining before, where since they're all physically connected, it doesn't need that because it knows. Like think of this router, like you're kind of thinking of it as like, oh, it's going this router, this, right? But imagine like a physical router. When you're plugging in, you're plugging like this. Like when you plug in network one and you plug in C or like C, like you're literally plugging in like right next to each other. So like it doesn't need the next hop for that because it's like literally like probably a connection right next to it. Does that make sense? Yeah, it like literally knows because it's like a part of yeah, yeah, yeah. So like for devices that are directly connected, they could always communicate, like no matter what. Because like if I were to plug in a switch into another switch, like it would just be able to communicate. Yeah, if they're physically connected, they could always communicate. If they're yeah, you need an IP route. That's why like it knows until D because it's physically connected to D. And it knows until C because it's physically connected to that. But like up until that point, like what's like imagine network one is a LAN. It doesn't know like what's in that LAN. Like it doesn't know what's going on like after that point, and that's what the route does. And then so once the route gets to there, like it's pretty autonomous because if you set this route, all traffic would work. Because like the only thing that like matters is that two routers are like working. And then so as long as the IP route is moving back and forth, like whatever traffic you'd send would work because it would just be like, okay, this is like approved address we like set it up logically, like we're allowed to do this, and like I don't know, that's how it works. So yeah, I don't know, like I didn't think like we'd have time to like think about it and stuff, but so this is how you would set it up. So when you're say you're router one, right? So you're going into D and you want to go to F, okay? So you set it up to where like F is your destination. So you start with your destination and you go from the next hop up until. And the same thing goes for the other one. You say the destination first and you go to the next hop until. And this applies if you added a router in between, you would keep just like adding for the next hop the router until, and then the destination will always be the same. So, all right, this is more of like a actual example with like a real like more, like realistic setup. So, and yeah, with the actual routes as well. Like this is how it works. So you start with PC1 and so F0-0. Yeah. So yeah, this one's like okay. Go to the next one. Yeah. So this one, yeah, like this one's a more interactive one. You start at like Pomona, for example, and imagine you want to send traffic from here up until like through this or through this, yeah. So what you want to do is like first your first device would have an address like 192.1.11. That's just like what you're sending from, right? And then the interface of the router is connected to has to have the same interface. Because what I was showing before, like you didn't see it, but like logically they're still broken up. Like they're broken up how I'm breaking up here, where it's like that's like its completely own address range. The middle one between the routers is its own address range, and then the one that is going to is its own address range. And that's why like the router can talk to one another is because those two are part of the same like each two is like it's like a Venn diagram where like each router is like it knows like the network is connected to and then the router like connection and the opposite is like it knows the network is connected to and the router and then the IP route like brings them together. Shoot, we don't have that much time. Uh so yeah, I don't know. I don't think I explained too much, but that's the this thing. And then yeah, so I'll just go into the syntax errors you commonly make. So this one's kind of like the like a super common practice is you would do like imagine you messed up a command and you just added a slash or something. Like I was trying to do enable and then I did like enable slash. Like what it would do is like it thinks like I don't know why naturally it thinks you're looking for a host name that's like whatever you searched up. So like en slash, like it thinks like that doesn't exist, but it spends 20 to 30 seconds like trying to find it. Like it's like, oh, what is like what DNS server is en slash? Even if it just because it's a typo. Like if you made any typo, it would do this. So what you would do is you do no IP domain lookup, and it'll just stop like trying to keep like finding domains to like search up that like every time you mess up something. And yeah, this is like super common practice like for a real router. And yeah, the only other one you'd see is probably ambiguous command, is where like when you're doing what I was doing, where it's like you're kind of cutting off where you say commands. Like I was doing en for enable. Like say for example you did ex for exit, like you're trying to exit the configuration line. It like for this one specifically, it's ambiguous because it doesn't know. Like also always use the question mark like during any of these. That's like the best thing you use in a router because it shows right under. It's like, do you mean this or this? Like do you mean set an executive timeout or set like do you want to exit? So it doesn't really know if you want to set like a timeout of your line console to be 3 minutes or if you want to leave. So you have to add more words to like specify. So like once I write the whole command, it understands, and once I write like the full exit command, and then notice how once I leave the config line, that exit works again because there's no ambiguous commands in the general configuration. All right, so for the most part, yeah, that's it. Come to Friday's lab where you set up this LAN right there, and yeah,